The race to win wars and explore the stars have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. Tents, the hiking essential developed on the military campaigns of history. Fire Extinguisher, the British Army captain whose invention revolutionised fire safety. Synthetic oil, how a lack of supplies in World War II led to the oil we use today. We reveal the amazing science and manufacture behind these wicked inventions. The military has continually needed and refined the deployment and design of the tent. From the Roman army of 2,000 years ago to the modern military machines of today, the same basic design principle of a suspended covering held in place by a combination of ropes and supports has provided shelter for troops out in the field.
The soldier spends most of his time doing nothing. You've got to stand in the same place, you've got to stay in the same place for a period of time. That means people have got to eat, they've got to sleep, they've got to do their paperwork and whatever else, and they need shelter. Tent provides portable shelter for a large army, and it provides survival shelter for a small group out in the countryside by themselves. But the essential is to keep out water and to keep out wind. Wind and water are the killers. So making the troops as comfortable as is reasonable is what you're after.
Originally, tents were covered in animal hides, such as goat skin in the case of the Romans. But as industrial production of fabrics developed, other materials started to be used, such as hemp and canvas. But these had their own drawbacks for soldiers such as those in the Napoleonic Wars of the late 18th and early 19th centuries.
The original tents were made of canvas, and they're fairly heavy. And you try and pick up a canvas tent and you really have got a problem. Also, canvas absorbs water. So the nastier the conditions are, the nastier the tent becomes. It becomes very, very heavy and difficult to move about. Modern tents are made out of very much more sophisticated materials, and they are light. They can be folded into a very small space and then put together, erected quickly, and they become highly efficient, where previously they were a sort of last resort, really.
The leisure tents used today are the result of thousands of years of military experience in the field, and for that reason, they are truly a wicked invention. Based in Chesterfield, England, Field Candy was launched in 2011 with the aim to produce unique, fashionable, spacious and practical tents to the camping market. Work begins with the design department. Using special graphic software, unique and custom designs can be tailor-made to fit the tent. These are then sent to a state-of-the-art industrial digital printer. Using environmentally safe UV printing, the designs are digitally added to a sheet of waterproof fabric.
Field Candy was developed and formed in our minds when we visited an exhibition in Germany. We saw two halls full of tents. They were all green and blue, and we felt there could be something better and more exciting done with the tents. So we came away and we formed Field Candy. We manufacture camping tents, which are 2 or 3 person tents, used in the outdoor sector for people who have hobbies or go camping or just enjoy the great outdoors. Our tents are slightly different insofar as we put designs onto them and make them artistic statements and parts of fun rather than just serious camping, although the tents are actually very good tents as well as being fun.
Once printed, the fabric is laid out for cutting, where a worker cuts the shape of the tent by hand. This is a careful process, as one slip could mean reprinting the whole design.
Historically, tents have been made of natural fibres. It's very different from today. When a natural fibre is produced into a tent, it is not inherently waterproof. It's only when the tent gets wet that the natural fibres expand to create a waterproof product. Today we use man-made fibres, in our case polyester, and that means the tent is waterproof already, so modern fabrics are a lot easier to deal with. They're also a lot lighter, and lightweight is important for most campers because they have to carry the product to wherever they're going to pitch.
Once the fabric has been cut into shapes and markers have been set for the string holes, it is ready for sewing. The fabric is sewn together in several stages. First, the two main sections of the tent are sewn together using a folding machine. That adds an extra waterproofing seam along the edge of the tent. A tent is a complicated product, as it needs to be light, easily assembled and durable. It has to be able to withstand severe weather, be very waterproof and not blow away under strong winds. It is therefore a challenge to create a tent that can keep you dry and warm, but also keep you cool in hot weather, as well as being light enough for easy transportation. The additional parts, such as the strengthening sections of PVC, the tent rings, pockets and hemming, are added to make the complete tent. The heavy-duty zip that includes an inner and outer toggle protected by a Velcro cover is added using a bar tack machine, which adds an extra strong stitch. The sewing process takes up to 2 hours per tent, as it is completely handmade. The eyelets for the poles are measured by hand and marked, then taken to a machine that stamps the holes through the fabric. As this has to be precise, each tent is put through quality control, where it is laid out over a pre-made frame to check all the holes are accurate.
A good camping tent must be durable, long-lasting, it must be comfortable and breathable, it must be very waterproof and not blow away in the wind. Our tents do all of that, but Field Candy's piece de resistance is the fact that we put a design on the outside of the tent. That causes us another issue of fade in the sunshine, and we use a special process to stop the print fading. So we create a fully waterproof product that is digitally printed to a very high standard and has all the other durable and long-lasting features of a traditional camping tent.
Once passed, it is taken for final inspection, where the fabric, zips and strings are checked before being neatly folded so it can be packed.
The beauty of tents is that they can be used in any situation, and you can see them on the top of a mountain or in a queue of a sail or on the beach. And I've got no doubt they'll continue to be used in unusual situations around the world.
All the components that make up the tent are securely packed into its matching fly sheet bag and placed into a matching outer carry bag, making it ready for distribution around the world. The tent, truly a wicked invention. For thousands of years we've been using fire in our homes, but as useful as this amazing element is, it has resulted in countless fatal fires throughout history, and this has led to many different methods to combat the flames.
There's always been lots of different ways to extinguish fires. Historically, for instance, we know that the Romans used a sort of bucket chain whereby buckets were passed down a chain of people and then the water was thrown over the fire to extinguish it. More recently, in about the 17th century, something called squirts was developed, which is a slightly unfortunate name perhaps, but quite an efficient way to put out a fire. And that was really based on the idea of directing jets of water over fire, and that was a little bit like a bicycle pump. You pulled a plunger out and sucked in the water and then pushed the plunger back in to direct this squirt of water over the fire. And in fact, it was the squirts that were used to extinguish the Great Fire of London in 1666.
Compared with the fire extinguishers we are familiar with today, extinguishers like the squirter seem amazingly primitive. But this principle was developed into larger fire engines operated by teams of men that could shoot water at flaming buildings from the street. These hand tubs, as they were known, were not very portable, but a visionary British inventor called Captain George William Mambi was going to change that with a revolutionary new firefighting piece of design.
He recognised that the firemen with fire engines couldn't shoot a stream of water up to the top stories of buildings. But if people could get in to the top stories of buildings with portable fire extinguisher materials, they could carve a way through to those who are trapped without injuring themselves in the process.
One of Mambi's life-saving inventions had been the Mambi mortar, which fired a life-saving line of rope from a mortar located on the shore to ships in distress. In 1813, Mambi took this idea of firing out a life-saving solution to his new idea for a portable fire extinguisher.
He invented the pressurized fire extinguisher by taking a large copper cauldron, putting pressure inside it, having water in there, and having potash, which is potassium carbonate, in the water, so that you could pressurize a jet, direct the jet where you wanted to, so it wasn't a general throwing a bucket of water and hoping. It was actually a much more directed and targeted approach at a flame. You could add water which has a high heat capacity, which means it will take a long while to heat up, and so it can cool quickly the fire. The potash likely was there to help keep the water from going stale and having bacterial growth, but it has the added side effect that if the fire is very hot, when the potash hits high temperature, it can release carbon dioxide, which will also help smother the flame at the same point. So it was a dual action approach to fire extinguishers.
Mambi's pioneering device would start the research and development that resulted in today's modern fire extinguisher, and its success was due to the fact that it tackled two elements of what is known as the fire triangle. A fire needs three elements for it to ignite: heat, fuel, and oxygen. If you take away any one of these three elements, a fire will quickly die. In Mambi's time, the commonest fuel would have been wood, but in our modern world, we have a wide variety of environments and materials that are combustible that would have rendered the original fire extinguisher obsolete in some situations. Though most fire extinguishers operate by firing a fire-fighting substance from a pressurized cylinder, like Mambi's original design, today a whole host of different materials are used.
We have different fire extinguishers for different types. First off, there is water. It works for many things. For petrol-based fires, for oil-based fires, it doesn't work very well because water and oil could produce a massive explosion because it vaporizes the steam. But for fires where what you're trying to extinguish is immobile, doesn't react with the water and won't explode, so like a normal log fire or wood fire, even parts of a house, that will work very well. Carbon dioxide also works on fires. It's very good because if a fire requires oxygen to survive and actually continue, you put carbon dioxide over it, there's no oxygen source, the fire is extinguished. What you have to be careful of is that if the material is still hot, once the carbon dioxide moves away, the fire can actually reignite. So fire safety is actually very seriously taken, and you have to understand what type of material you should be using on which type.
Now available in 6 main types, which include water, foam, carbon dioxide, dry powder, wet chemical, and metal, the modern fire extinguisher is a far cry from Captain Mambi's original life-saving device. But it is still a wicked invention. Like George William Mambi, our intrepid tester fancies himself as a bit of an inventor extraordinaire, and today he's going to show you how to make your own marvellous mini fire extinguisher out of a few household items. What you will need: bicarbonate of soda, also known as baking soda, vinegar, matches, some tea light candles, and a plastic bottle. To begin, ignite the fire, or in this case, arrange 8 tea lights and light them with a match. As always with fire, take precautions and only conduct the experiment in a safe place well away from combustible materials. Take the vinegar and carefully pour in about 100 millilitres into the empty plastic bottle. Now add 2 to 3 heaped teaspoons of the bicarbonate of soda to the vinegar. Screw on the bottle top and shake to mix the 2 ingredients together. The bicarbonate of soda and vinegar react, creating bubbles of carbon dioxide gas. Let the mixture continue to react for a few moments and then gently unscrew the cap and pour the gas over the candle's flame. Even though the carbon dioxide is invisible, the gas is actually heavier than air and so can fall out of the bottle with a gentle tip. The gas displaces the ambient air around the flames, starving it of oxygen. And there you go, our mini fire extinguisher has done its work and put out all the candles. But how does this nifty party trick work? Vinegar is sour because it contains acetic acid, and this reacts with sodium bicarbonate that is present in the powder to create carbonic acid. The carbonic acid is unstable and immediately breaks down into carbon dioxide and water, and the bubbles is the carbon dioxide escaping from the liquid. So, instead of one reaction, we are actually seeing two. So there you have it, your own mini fire extinguisher. Or you could just blow the candles out yourself. It is essential to the smooth running of engines all around the world, but its successful development originated in war-torn Germany. It is synthetic oil.
In vehicles, anything that moves, you want to make sure moves freely and fluidly. If you have two metal surfaces moving against one another, without a lubricant in between of any kind, the metal surfaces will grate. So in the engine you use a thick oil that's normally at room temperature quite hard to move around, but when it's heated up in the engine, it becomes a fluid oil, and so you can allow the bearings and all the pistons to move quite quickly and smoothly so that your engine is efficient.
Lubricating oils created from natural petroleum had been in existence since the late 1860s, but its weaknesses, such as a tendency to freeze at very low temperatures, led to attempts to create alternative lubrication oils from synthetic or man-made materials. The early 20th century saw successful small-scale production of synthetic oils, but the unique demands of World War II would lead to a catalyst in its development.
During World War II, there was a shortage of all sorts of different materials, and synthetic oil was really developed as an alternative to petroleum, so that they could use man-made compounds instead of mineral, natural ones that weren't always readily available. And it turns out that actually synthetic oil is really beneficial to machinery, and that actually in the end it helped wartime equipment function better than maybe natural petroleum might have.
With no natural reserves of their own and the Allies throttling the supplies that they did control, Nazi Germany successfully developed synthetic fuels and oils during the 1940s.
So the Germans started to work out how to make kerosene from different materials, whether it be plant materials or from coal, because coal is a natural source of hydrocarbons from which you can make oil. And this was perfected during the apartheid era in South Africa. It's called the Fischer-Tropsch process. You take what's called synthetic gas or synth gas, which is basically carbon dioxide or carbon monoxide and hydrogen, and in a preheated pressure vessel you produce oils and hydrocarbons of different lengths. The very fine hydrocarbons, the very light ones, come off first, and you may refine them and re-crack them to make longer ones, and this produces a synthetic oil.
It may have been an answer to dwindling natural supplies, but because of its superior performance, synthetic oil is now used far more than natural petroleum lubrication. Developed from the necessity of war, but keeping your car healthy today, synthetic oil, truly a wicked invention. Miller's Oil is a British-based company and has been trading for 125 years. To this day, it is still a family-run business. The first stage of production is receiving the raw materials, which consist of synthetic-based stock, which has been sent from the refinery. At any one time, this plant can store between 1,500 to 2,000 tonnes of stock in their on-site tank farms.
The product we've been making today is a synthetic 5W30 multi-vehicle type passenger car oil. The challenges in making synthetic engine oils are sourcing high quality, repeatable quality feedstocks and additives. The process we use is very accurate and using the most high quality raw materials that we can gives the best end result. A typical processing time for this type of product largely depends on how quickly you can get the raw materials in and out of the blending vessel. Some are quite easily moved by pumps, other raw materials are quite viscous and sticky and have to be poured into the blending vessel manually. But the blend that we're making today, I estimate, will take between 3 and 4 hours.
The raw materials are then either pumped or poured into a blending vessel. This is where all the ingredients are added and mixed. This particular ingredient is a detergent inhibitor, a vital part of the motor oil, as it contains a lot of the performance-related additives. It is poured manually into the vessel from above, because it is too thick for the pumps to transfer it. Performance additives are vital for proper lubrication and prolonged use of oil in the modern-day engine. Without these, oil would break down, become contaminated, and not protect the engine at all. All the ingredients are carefully added together and mixed inside the vessel, either from a computer-generated blend or a stored recipe that has been used previously. The mix is then heated and agitated to ensure a consistent blend is achieved. Before completion, a sample is taken and sent via air tubes to the laboratories. Here it will be inspected and put through multiple tests to make sure it meets the standard design requirements.
Synthetic oil has evolved over the years, mainly because of several factors. One is the improvements in the refining process, which produces a lot more precise base oils in terms of the amount of sulphur that's in them and other impurities. And the other factors involved are the hardware that the oil is used in, i.e. the car's engines, meant that they were producing more power. There was a desire to have longer oil drain intervals, so rather than have 1,000 miles or 1,500 miles, people were going to 6,000 miles or a year, and where we're at now is engine oil drain intervals are at 2 years typically, or 20,000 miles.
Some of the tests performed in these labs include a cold crank simulator. This machine simulates a car's engine starting up in cold conditions, such as minus 30 degrees Fahrenheit. Next is an X-ray fluorescent spectrometer, where X-rays are passed through the sample to extract information about all the additives that are inside. A viscometer is a simple but important test, which measures the resistance of flow within the sample during high temperatures. In this example, the oil's operating temperature is upwards of 100 degrees Celsius. Next is the 3-place digital density meter, which can measure the sample's density, specific gravity, or display the concentration of aqueous solutions, or how thick the oil is in layman's terms. And finally, there is the inductively coupled plasma. When the green torch is on, an intense electromagnetic field is created and it is able to pick up any trace of metals within the sample, similar to a blood test.
The development of synthetic oils has just continued and continued. In fact, most new vehicles only use synthetic oils because everybody is chasing lower and lower emissions. CO2 per kilometre is very much in the news because of the greenhouse effect, company car tax, etc., etc. Lower and lower emissions are here to stay. But it does mean that after-treatment equipment such as catalytic converters and diesel particulate filters will only work properly with synthetic engine oils.
It is not until all the tests and characteristics have been fulfilled that the oil can be sent for packaging. The whole process from start to finish has taken up to 4 hours to get to the packing stage. Multiple containers are filled automatically by a dispenser, which pours the exact amount of fresh oil into each bottle. The bottle caps are specially fitted, sealing the bottle so it can be packaged and sent out for delivery, where it is used all over the world. Synthetic oil, truly a wicked invention. So there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. Tents, fire extinguishers and synthetic oil, all wicked inventions.